Hi everyone. So today we are going to look into a key technical word in the machine learning world. It's called dimension, right? You would have come across this term when you are having multi-dimensional features. When people say you have multi-dimensional features, it means you have uh, inputs to the algorithm which are more than one, right? So you have multiple signals that could be used to model your data. So that is multi-dimension. So before getting to know what multi-dimension is, let's understand what a single dimension or a two dimension or a three dimension is, right? So imagine you driving a car on a highway, right? So you're not going to take any left, right, or get distracted. Just focus on driving on a straight road. So this is same as single dimension. You are in the first dimension here, right? And this can be compared to machine learning world wherein there are some time series, univariate time series problems, right? So wherein just a single feature is being used to predict an outcome, sorry, or an output, right? So this is univariate time series, and this can be compared to single dimension, right? Now let's understand what 2D is. Now we are adding one more dimension, right? So in this case, the same person, I mean, you driving a car, now you are going to take a left or a right, right? So when you take this left or right, you are entering into the second dimension, right? So you just imagine, right? People when they start to drive a car, it is easier for them to drive on a straight road, but it is difficult at that time. It is difficult to take a left or right, right? So when the dimension increases, complexity of the problem also increases, right? So I would like you to have this thing in the mind firmly, right? So whenever some dimension increases, right, the complexity of the problem is increases. You should have that representation to understand it, right? So taking left or right can be compared to two dimension. So two dimension in ML world can be you having features, right? Two different features to model your data. So that is two dimension. Now three dimension, the problems gets a bit more complicated, wherein you have to add one more dimension, right? So in this case, the driver can drive into a tunnel or a flyover, right? So we are adding a third dimension, which is depth here. So earlier in this two dimension, we took left or right, right? This could be uh, breadth, right? Or the first dimension could be length, second dimension could be breadth, and the third dimension is a depth or height. Now again, if you think, right, so when you're driving a car, when at that time it is difficult to take a flyover, right? Mentally it is difficult. So you are into the third dimension, the problem is bit more complicated compared to the second dimension. So this can also be compared with ML algorithms too. The algorithm should be robust enough to understand the dimensions. Only then it can better understand the patterns in the data and give you a good prediction, right? So I just have this one liner in your mind. As the dimensionality increases, the complexity of the problem also increases. Hope your algorithm is good enough to understand this complexity and drive the pattern in your data. Thank you. If you like this video, please subscribe the channel, like, give me a thumbs up, or please share it with someone who might find this interesting or useful. Thank you.